Hi folks, I'm going to review the I'm going to go through the rest of the problems that were on the review sheet and work through the solution step by step for each of the problems. We did 1 through 6 in the last video, and this one we're going to do the remainder of the problem. So the first one we have here is problem number 7. And we're given that ln of 4 is x and ln of 5 is y. These problems can sometimes get tricky because people sort of mess up what's getting substituted in for what. So the first thing we want to do is expand out the problem that we have, and then we'll go ahead and substitute in the x and the y's. So we have ln of the square root of 4 over 25. I can actually rewrite that as ln of 4 over 25 to the 1/2 power. Remember, when you take the square root of something, you can write that as a fractional exponent. The denominator of that fraction is the root you're taking. So if it was a cube root, it would be to the 1/3 power. If it was a 6th root, it would be to the 1/6 power, etc., etc. Okay, so now I can go ahead and use my power rule. If I bring that out in front, I end up with 1/2 times ln of 4 over 25. And here's where you have to be careful. It's 1/2 times ln of 4 over 25. So you have to now, when you expand the 4 over 25, you have to put that in parentheses because that 1/2 applies to that whole thing. So it's 1/2 parentheses and then ln of 4 minus ln of 25. Okay, we're not quite done yet because there's a couple of other things we can do here. I can rewrite this as 1/2 ln of 4 minus 1/2 ln of 25. Okay, so all I did was distribute that 1/2. 1/2 ln of 4. And then here, remember, 25 is really the same as 5 squared. So I can rewrite that as 5 squared. And then if I use my power rule again and bring that 2 out in front, 2 times that 1/2 would just be 1. So it would just be minus ln of 5. And now I can go ahead and substitute in. I end up with 1/2 x, because ln of 4 is equal to x, minus y. So a couple of steps there. If you didn't do it exactly in that order, let's say back here you converted ln of 25, that's okay. As long as you end up with the same answer, you're fine. Okay, let's look at part B, ln of 80. So you're going to have to figure out what those factors of 80 are that you want to use. You can use 16 and 5. So if I have ln of 16 times 5, right, then I can use my product rule and I can say, well, that's ln of 16 plus ln of 5. And I don't have an expression for ln of 16, but I can actually rewrite that as ln of 4 squared plus ln of 5. And then again, I can use my power rule, so I have 2 ln of 4 plus ln of 5. And now if I go ahead and substitute in, I end up with 2x plus y. So that's just some practice with expanding out using your rules or your properties, expanding them out, and then substituting in. Problem number 8 is just solving a log equation. Remember, we want to get this into terms of a single log. We want to condense it down to 1 log, and then we can go ahead and solve it. So I have a couple of things going on here. I have the product rule and the power rule. I'm going to undo that power rule first. So I have log base 3 of x plus log base 3 of 81 to the 1/2 power is equal to log base 3 of 2 to the 4th. I undid the power rule there as well. Okay. Now I can undo my product rule. Keep in mind here that 81 to the 1/2 power is just the square root of 81, so I can actually rewrite that. So I end up with log base 3 of 9x. So I'm kind of combining two steps in one. 81 to the 1/2 is just 9. And then because I'm adding them, I can use the product rule. So it becomes log base 3 of 9x is equal to log base 3 of 2 to the 4th, which is 16. Because I have logs on both sides and I have this equal sign, that must mean that 9x is equal to 16. And so x is equal to 16 over 9 when you go ahead and solve that. Okay, so not too difficult. If you're comfortable with your rules and your properties, it should be okay. Similar, number 9 is similar. Again, we're using our rules. We're using our quotient rule. So that would be log base 6 of 72 over 2, which is just log base 6 of 36. And 6 to what power gives me 36? 6 to the 2nd power. So the answer there is 2. This one tends to give people a little bit of an issue. Remember, we need a common base, so we're going to actually have to convert both of these to a common base. I know that 25 is 5 squared. I know that 125 is 5 cubed. So notice I'm not changing the value of anything. I'm just rewriting these so that I have a common base. So I can rewrite this as 5 squared to the x minus 2, and this would be 5 cubed to the x minus 2. When you raise an exponent to a power, you multiply them together, so you end up with 5 to the 2x minus 4 is equal to 5 to the 3x minus 6. And now I have a common base, so I can set my exponents equal to each other. 2x minus 4 is equal to 3x minus 6. And when I solve that, if I subtract 2x from both sides, add 6 to both sides, I end up with x is 2. This one tends to also give people some trouble, but again, make sure you kind of look at it sort of from a I don't know, not. People sometimes think I have to multiply 100 times 1.2970 and then take the log of that. And that's not the case. M is not equal to 1.2970. The log of M is equal to that. So when you look here, you want to say, well, what can I do with that? How can I break this up so that I end up with log of M? Well, I can use my product rule. So the log of 100M is the same as log of 100 plus the log of m. Okay? And remember, there's no base written here, so that means it's base 10. So log of 100 is just 2, right? 10 to the 2nd power gives me 100. And I have a value for log of m. It's just 1.2970. And so my final answer then is very easy, is just 3.2970. So sometimes a problem looks like it would be more complicated than it actually is. And I believe actually that was a multiple choice problem, so that would have been choice 3 there. Okay. Number 12, write as a single log. So we've got a lot of different things going on here, right? Just like any other problem, you want to take care of the parentheses first. You want to kind of follow order of operations. So this is the same as 1/6 to the, or times ln of y plus ln of x to the 5th. So I'm undoing my power rule there. I'm going to undo my power rule here. And I'm going to undo my power rule here. I can undo my product rule, so this becomes 1/6 times ln of y x to the 5th plus ln of z to the 3rd minus ln of c to the 1/2. I'm going to kind of keep writing down in this general direction here. So this is 1/6. Now if I undo, this is also the power rule. It's being applied to this whole term yx to the 5th. Okay, so remember it's a fractional exponent. So that's the same as taking the 6th root. So I can actually rewrite this as ln. I'm going to write it a little bit neater. Here's ln, and that's a 6 there. 6th root of x to the 5th y, because typically you write an x before you would write a y. Right, plus ln of z to the 3rd minus ln of c to the 1/2. C to the 1/2 then, that's the same as the square root of c. So I can write that as the square root of c. And so now I'm going to combine everything into a single log. Here I have the product rule, here I have the quotient rule. So if I rewrite this, I end up with ln of the 6th root, so the 6th root of x to the 5th times y times z to the 3rd, all of this over the square root of c. And I would write the ln out in front of that whole thing there. So it would be ln of that whole thing. Okay, so you just have to be careful with the parentheses there, but if you just take it one step at a time, it's not too difficult of a problem. Problem number 13 then is just solving a log equation. So I'm going to undo my quotient rule. I end up with log base 4 of x squared minus 4 over x plus 2 is equal to 1. Now, sometimes people, and it's wrong to do this, but sometimes people want to go ahead and factor this and then cancel. You can't do that at this point because then you're possibly excluding a solution to the problem. So you don't want to be canceling anything out. You want to solve for all possible values of x. Then at the end, when you check, then you can start to exclude. So I'm going to take this out of log form. 4 is my base, so 4 to the 1st is 4. So I end up with x squared minus 4 over x plus 2 is equal to 4. I'm going to go ahead and cross multiply, so I end up with x squared minus 4 is equal to 4x plus 8. Bring everything over to one side. I'm just going to section this off so it doesn't get messed up. Move everything over to one side, so you end up with x squared minus 4x and minus 12 is equal to 0, right? When I bring both of those terms over, that gives me x minus 6 and x plus 2 as my factors, which means that x equals 6 and x equals negative 2 are my solutions. Now, if either of those don't work, then you would have to back in the original problem, then you have to reject them as solutions. 6 doesn't make anything 0, doesn't make anything negative, so that's okay. Negative 2 would make them 0, so you have to eliminate that as a solution. So your only solution here is x equals 6. Okay, and some people, like I said, they want to eliminate that here, and even though it doesn't work as a solution, you can't eliminate it until the end. Technically, it's wrong to eliminate it ahead of time. So those are the solutions to all of the problems on that review sheet. I'll be sending you another review sheet, and I'll start putting some videos together with solutions to that one. Okay, have a great day, everybody.